This is lecture 3 for week 15 of CS 1030. In this lecture, we're going to talk about functional abstraction in Java. And functional abstraction, if you remember, is taking a program and breaking it into appropriately sized and sort of appropriately defined functions so you can make writing your program easier. And this is a theme we've sort of talked about several times before in this course. And the reason we keep talking about it is it's one of the most important things for you to learn as a computer programmer. So let's consider a square. So you can see that there might be a bunch of different things that we care about this square. We might care that it's colored blue. We might care that it's on a yellow background. That's not what we're going to talk about right now. What we're going to do right now is assume that the only thing we care about when looking at the square is the length of the side. And so, obviously this is for purposes of the lecture here, we're just assuming that that's the important thing. If you're in a different set of circumstances, like you're programming a computer game or something, you might care about a completely different set of things about the square. We're just sort of doing this for sake of argument. So we're saying that what we care about a square is just the length of its side. And now we want to write some Java code that performs computations about the square based on what we know about the square. And so we start doing that by representing what we know about the square in Java code. So we're going to declare a function main, and the way we declare that function is how we saw in previous lectures. So we have a function called main, and remember again, main is where the Java program starts executing. And we've made a new variable called side length, and we're going to initialize it to 3, and that's going to represent the length of a side of the square that we're talking about. So now that we have some data which stores what we cared about the square, we want to ask, what is it that we might want to compute about the square? What do we want to do with this information that we've written down about the square? And so, for example, we might want to do something like compute the area of the square and compute the perimeter of the square. And so let's look at that in a little bit more detail. So what we can do is we can write, or we can declare a new Java variable called area. It's also an integer, and area is going to be initialized to side length times side length. And so, of course, that's the correct way to compute the area of a square. And so now area is going to contain 9, which is in fact the area of a square, which has side length 3. We're also going to declare a new variable called perimeter, which is initialized to 4 times side length. And so, of course, that's the formula for computing the perimeter of a square. So that's going to get the value 12, which is the correct perimeter for a square of side length 3. One thing you might ask yourself here is, why are we doing integer arithmetic? Why did we declare these things all as integers? And really, it's just to kind of make things easier. In real life, you might do this as a double. You might not. It just depends on what you're actually trying to accomplish here. So now let's ask the question, what if we had another square? What if we wanted to represent 2 squares in the same computer program? Well, one way we could do that is we could just declare a new set of variables. So we'll make a side length 2. This is the length of the side of the second square, the red one shown on the slide. And we'll initialize area 2 to be side length 2 times side length 2, and perimeter 2 to be 4 times side length 2. So now, of course, these are going to contain 1 and 4, which are respectively the correct area and perimeter for a square of side length 1. And so what we're going to see here is that this is kind of the obvious way to do this. This is sort of what you or I would probably first write down when trying to do a program which does some computations about squares. What we're going to see is this sort of isn't really kind of the optimal way to do it. We can see that by breaking the code into functions, we're going to be able to do a better job. And to sort of start to see why that's the case, let's ask, what if we wanted to represent more things about the square? Like, what if we wanted to represent its position, its x and y coordinates on the plane of where it lives? What if we wanted to represent its color? What if we wanted to represent something like how much it weighs? We'd need a lot of different variables for each square. And now, when we start repeating all those variables for new squares in our program, we're going to have to make copies of all of them. And we're going to have to make copies of the code which does computations on them. And it's going to start to become not only kind of bloaty and ugly of a program, but there's also going to be a lot of possibility for error as we start copying code around. So that's not how we want to go. So what we want to do is abstract the code into functions, and then we'll be able to call a function about a square for any of the squares we've created. And this is going to sort of reduce duplication in our program and make it easier to read. And so let's look at how that's going to work. So a function in Java is very much analogous to a function in Reduced C, and also very much analogous to a custom block in Scratch. So it's a piece of code that takes some values and does some computation on them and returns an answer. So it turns out that Java functions actually even look a lot like Reduced C functions. And so here you can see a sort of a template for a Java function. So every function has a name. And the reason the function has a name is because we're going to need to be able to call it by using that name. So in some other part of the program we want to call it, we just supply the name of the function. The function is going to take some input parameters optionally. That's data which is going to be passed into the function that it's going to use in order to do some computation. There's a collection of Java statements inside the function, inside the curly braces here. This is code that's going to do computation based on the input parameters. And then finally, the function is going to return a value of return type, and return type is just a shorthand on the slide here for one of the data types that Java supports. And so the 4 types that we've seen so far are int, double, char, and Boolean. And of course, a Java function can return any of those. Okay, so now let's apply this idea to the square example. So here's a function that returns the area of a square. So the function is called getArea. So it's always good to choose good names for our functions. The parameter that it takes a single parameter, which is an integer called square width, and the body of the function just returns square width times square width, and then the function returns an integer value, and let's not worry about the static right now. So that's the getArea function, and now let's look at what that did to our main. So we've still made a new variable of type int called sidelength and initializes it to 3, but now to compute the area of the function, instead of doing the multiplication sort of right here, we just call getArea on sidelength, and that's going to do the multiplication and return the value 9 in this case, to our new variable called area. And then we can print area equals whatever the value of that is, whatever the value of stored in area, which of course is 9 here. So let's look about how that works a little bit more. So let's just sort of, again, we're sort of just making absolutely sure we understand how this works. So we've declared a new variable called sidelength, which has value 3. That 3 gets passed to the function because we specify the variable sidelength here as an argument to the function. Okay, so that gets copied to the function, and here now the value 3 is called square width. And so there's no reason that the name, that these names would have to be the same. And in fact, those names would very often be different. So the thing that's the same is the value is the same. The value 3 gets passed into the getArea function. Now inside the getArea function, that value is available and we can do computation with it. So here we're just multiplying it times itself. And when we return it, then it gets used as the return value of the function because we said to return it, and it gets stored into area. Okay, and now once we have that value as area, we're free to do something else with it, like print it. Okay, so now the main function, assuming we also have a function called getParameter, which we sort of define analogously to getArea, the main part of our Java program now says int sidelength equals 3, int area equals getArea, and we pass it sidelength, and int parameter equals getParameter of sidelength. And the effect is the same as the original function we saw, but now it's just a lot easier to read the code because it contains some hints of what things are doing. And there's also less code here because we're not doing the math inline, we're doing the math elsewhere. And generally speaking, if you do a good job at breaking up a program like this, it not only makes the program shorter, but it also makes the program easier to read for yourself and for other people.